So this video is going to go over calculations having to do with stoichiometry with liter-to-liter calculations with gases only, and also talk about some particle calculations as well. So we have a relationship with moles and liters of a gas at STP. So we could use that to do a series of calculations with it, again with the balanced chemical equation. So if I take this balanced reaction, all being gases, I could actually calculate how many liters of any of these species from a beginning point. So it's at 24.8 liters of SO3. I want to find the liters of O2. So again, reason this is called liter to liter is I'm starting with liters and I'm ending with liters. So I'm going to take my my given and I'm going to say, okay, well, how many moles is this? So I know that for every 22.4 liters, I have 1 mole at STP. So I could set up my proportion. So again, all of these problems, the first thing you're going to do is go to moles. First things you're going to do is go to moles. So cross multiply and I find that X is equal to 1.10 moles of SO3. The second part, again, so this is liters going to moles. The second part is using the balanced chemical equation. And I'm going to go from moles of SO3 to moles of O2. So I'm going to take my 1.11 moles of SO3, and I'm just going to say how many moles of O2 is going to be in that relationship. So again, I have to look back at my chemical reaction. I see that there's a 2 in front of the SO3 and there's a 1 in front of the O2. So I have 1 mole of O2 goes on the bottom, 2 moles of SO3 go on top. So again, I cross multiply 1.11 divided by 2. X is going to be 0.554 moles of O2. And again, with all of these problems, it is the best thing for you to label your units, including what species you are talking about. So then I want to go to liters of O2. Okay, so I'm going to say, okay, how many liters is in 0.554 moles if I know 22.4 liters is for every 1 mole? So I cross multiply, my X comes out to be 12.4 liters of O2. So again, this is called a liter to liter problem because I started with liters and I end with liters. So this is my final answer with 3 sig figs. So you do 3 steps. You convert to moles, you use the balanced chemical equation, and this last step, I'm converting moles to liters. Okay, converting moles to liters. Now, using the same balanced equation, I just want to point out that with this type of calculation, liter to liter, you could actually do kind of a shortcut to the answer. So how many liters of SO3 can be produced from 60.8 liters of SO2? This only works if you're going from liters to liters, by the way. If you are going from liters to something else, you can't do this. So since I have 60.8 liters of SO2, and I want to go to liters of SO3, because the first step is always going to be 22.4 liters and the last step is always 22.4 liters. If I have, all I have to really do is look at the relationship between SO2 and SO3 because I'm always going to be dividing by 22.4 and then multiplying by 22.4. So with this type of relationship, since they are both 2 to 2, I could just write down for every 2 moles of SO2, I'm going to have 2 moles of SO3, okay? And instead of doing all of that math steps, I could just say, okay, well then 60.8 liters is going to be my liters of SO3 because the relationship in the middle is going to be 2 to 2. And it's going to start off by dividing by 22.4 and then multiplying by 22.4. So I have this easily done without having to do all of the additional steps. So another type of calculation that we're going to be doing is what we call particle calculations. And particle calculations have to do with, again, we have relationships between atoms, molecules, and formula units with the Avogadro's number of 6.02 times 10 to the 23rd. So instead of going from liters to liters, I'm now going to go from liters to molecules, for example. And I could do any calculation I want as long as I have that magic number of 6.02 times 10 to the 23rd. So I'm going to use the same balanced equation, and instead of, I'm going to start with liters and go to molecules. So Again, the first step is always going to moles, no matter what type of problem I see. So if I go from liters to moles, I'm going to take 52.8 liters. I'm going to say, how many moles is that? If I know 22.4 liters is the same as 1 mole. So that comes out to be 2.36 moles of O2. Next step is always the balanced chemical equation. So I have 2.36 moles of O2. I want to know how many moles of SO3. And you might be saying, well, how do I know what I'm looking for? Well, that's what's given in the problem. So I'm going from moles of O2 to moles of SO3. So I know O2, there is a 1 in front of it, and there is a 2 in front of the SO3. So it's a 1 to 2 relationship. So I'm going to be multiplying the 2 times the 2.36. So it comes out to be 4.71 moles of SO3. So in the previous problem, I then converted to liters, but this one, I want to go to molecules. So how many molecules are in 4.71 moles of SO3? So I'm going to be using 6.02 times 10 to the 23rd molecules for every 1 mole. Now again, why is this called a molecule and not a formula unit? Well, that's because sulfur and oxygen are both non-metals. And so if it's a non-metal, I'm going to be calling it a molecule, not a formula unit. So I take the moles times Avogadro's number and I get 2.84 times 10 to the 24th molecules of SO3. So again, all of these, so I'm going from moles to molecules in this last step. So what you're going to see on our worksheets is the fact that there's a little box on top that kind of gives you a place for you to put what you are doing in each step. And again, if you have a different way of doing this, as long as you show me these 3 steps or you show me the relationships, I could see where your numbers are coming from.